So, good day, students. We're going to be doing lesson 6-2, parallelograms. And, and so we begin. So for 6-2, sides and angles of parallelograms. A quadrilateral with both pairs of opposite sides parallel is a parallelogram. Here are 4 important properties of parallelograms. Property number 1. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So for the example over here, PQ is congruent to SR. So in other words, it's telling us, hey, you know what? PQ, that means this side is congruent to SR. And then it says the other ones is going to be PS is going to be congruent to QR. And that is what we have right there. Okay, next property. If a quadrilateral is a parallelogram, then its opposite angles are congruent. So angle P is congruent to angle R, angle S is congruent to angle Q. So what we see over here is that angle P is congruent to angle R, and then we say angle S is congruent to angle Q. Okay, so those are the properties that we have. Okay, so what else do we see here? We see that if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. And it says here P and S are supplementary, S and R are supplementary. So in other words, what it's saying is angle P added to angle S needs to equal 180. Angle P added to angle Q needs to equal 180. Angle Q added to angle P, 180. Angle Q added to angle R is 180. Angle R added to angle Q, 180. Angle R added to angle S, 180. Angle S added to P is 180. Angle S added to R is 180. In other words, the green angles added to the red angles is going to be 180. That's, in other words, what it's saying. If a parallelogram has one right angle, then it has 4 right angles. Well, here's the big situation over here. If angle S happens to be 90 degrees, makes it a right angle. So if angle S is a right angle, then the opposite angle is going to also be a 90 degree or a right angle. So being this one 90 degrees and that other 90 degrees, give no other option but to angle P and angle R be 90 degrees as well. So it takes only one angle to be 90 degrees, and then all 4 angles will be 90 degrees. Okay, so when we go over the examples, we look at this problem. It says that it is a parallelogram. We read, and it said, hey, if ABCD is a parallelogram, find the value of each variable. So as you can see, we need to understand that AB is congruent to DC. Therefore, 2A equals 34, and you do the algebra from there. And then the other thing that we need to understand is that the opposite angles are going to be congruent. So AB equals 112. And then you do the algebra from there. And that is the example. So let's go over a couple of problems. We see over here that I have a 90-degree angle. I can clearly see that I have a 90-degree angle. Immediately, then I can say, hey, you know what? All the angles are going to be 90 degrees. So now I can say 3x equals 90 degrees. And I can also say 4y equals 90 degrees. So let me go like this. So now you do a little bit of algebra. You divide by 3. X equals 30, and you're done with that problem. And then for the other one, you divide by 4, you divide by 4, and then you say y equals 22.5. Just like that. And you are done with that problem. Okay, let's take a look at problem number 2. Once again, we see over here a 90-degree angle right there. So immediately we can say, you know what? All angles are 90 degrees. So immediately now we can say 6x equals 90 degrees. So let's divide by 6, x equals 15. Now for the side, I know that opposite sides are going to be congruent. So for this one, we say 8y equals 88. You divide by 8, you divide by 8, y equals 11. And you're done with this other problem. Problem number 3. We clearly see that we have 4 sides. All 4 of them are congruent. So given that this situation, all of them are congruent, I can say 6x equals 12, and I can also say 3y equals 12. You do a little bit of algebra. That's the end of the geometry right there. You just do a little bit of algebra. You divide by 6, you divide by 6, x equals 2. You're done with the x. You divide by 3, you divide by 3, y equals 4, and you're done with this problem. Now for this one, what are the things that we know? We know that opposite angles are going to be congruent to each other. So that means this angle and that other one are congruent. And I say that this one and that other one are congruent. So I know green is congruent to green, pink is congruent to pink, but these two added together needs to equal 180. And these two added together needs to equal 180. I see down here at the bottom that these two, let me show you the letters again, or the variables, should I say. I see x and I see x. That means that these two angles added together are going to equal 180. So I'm going to start right there. I'm going to say, hey, you know what? 6x added to 12x is going to be 180. This, when I solve this, basically that's the end of the geometry for that part. We're going to do a little bit of algebra. We're going to say 18x equals 180. You divide by 18, you divide by 18, and then you have x equals 10. Now, the important thing about the x equals 10 is that now I can take this x and I can plug it back. I can plug it back here and there. Okay? And when I plug that in, it's going to give me the value of both angles. So 10 times 6, this angle right here is going to be 60 degrees, while this other one, 12 times 10, this angle is going to be 120. The important part here is understanding that this 120 degrees is going to be congruent to the opposite angle. So now I can say that 3y is 120 degrees as well. We are going to now divide by 3, y equals 40. And just like that, we were able to find x and y for this problem. Let's go to problem number 5. So in problem number 5, we're going to apply a couple of things that we have learned, so far. So things that we have learned so far. Let's take a look at these two put together. Okay, so if I take 60 and I add 55, that will give me 120. and 11 degrees for green. So all this part as well has to be 115 degrees. But I know that if I take this angle and I add it to that other one, needs to equal 180. So I know that, let's say this one over here is red. Let's say over here is red, okay? I know that green added to red, for this particular case, needs to equal 180. So what I know is that green is 115. Now added to red, I don't care if you go X or you go Y, it doesn't really matter, but added to red is going to be 180. So let's make this easy. Let's take let's say X. Let's say that we're gonna do 5X, and those two added together needs to equal 180 degrees. So now we're going to do a little bit of algebra. We're going to subtract 115. We're going to subtract 115. Of course, that cancels out. You have your 5x equals, so 10 minus 5 is going to be 5. Let me do that in black so that we know that we are keeping the colors consistent. So 7, and here we have a 10. So this is a 5, that is a 6, and now we are going to, and then of course 0 for 1 minus 1. So now we're going to divide by 5. We divide by 5, and x equals 13. Okay, and that's it. Basically, that's it. For the other part, I mean, we have different ways of viewing this. We can redo the same situation. You know, we can redo the same for y, or we can understand that 5x equals 65. You see, the angle 5x is equal to 65. So I know what the red angle is. Here is the red angle, and I know that the red angle is going to be 65. That means over here, this one is also 65. I don't need to calculate. I already know that 2y is 65. Therefore, I'm just going to divide by 2, and then I'm going to say y equals 32.5. This way, I just skip all this algebra. I just skipped the whole algebra right here. Because right here 5x equals 65, that tells me the red angle is 65, so I know what this other one is 65. And that's it for problem number 5. Over here, this one is going to be a lot easier, a lot simpler. So we see that the opposite sides are going to be congruent, so this side is congruent to that other side, and blue side is congruent to blue side. Now pay attention here, because we have on red we have an x and we have a y. It's going to be really difficult to solve for two variables when you only have one equation. However, on the blue, you see over here, these two sides are congruent to each other, so we can write an equation right now, and we can say, you know what, 30x equals 150. Let's divide by 30. Let's divide by 30. X equals 5. Okay. So now that I know what x is, I can definitely come over here and say, hey, you know what? I can plug it right there, and now I can solve for the red, knowing now what that side is. So you load your calculator. And you say, you know what, 72, 72, I did a mistake over here. This is supposed to be a 5. 72 times 5 equals 360. So this is 360. Now I know exactly what the top side is. 2y is 360. So I'm going to write that because this is 360. 2y equals 360. You divide by 2. You divide by 2. Y equals 180. And you're done with problem number 6. So those are all the problems for the first half of the lesson. Now let's learn a little bit more. We know, let me go right here. We know, wonder what that is. Okay, so here we go. Diagonals of parallelograms. Two important properties of parallelogram deal with their diagonals. If a quadrilateral is a parallelogram, then its diagonal bisect each other. And says AP equals to PC, DP equals to PB. Well, let me explain to you what it's really saying. It's saying that when they intersect, when the diagonals intersect, then that point of intersection is in the midpoint between A and C. And it's in the midpoint between D and B. So that being in the midpoint, it divides the diagonal into two congruent parts. Both diagonals are being divided into two congruent parts. That's basically what it says on that one. Okay, if a quadrilateral is a parallelogram, then each diagonal separates the parallelogram into two congruent triangles. So what it's saying over here is that diagonal AC is splitting the parallelogram into let me see if I can color code this for you to see. This triangle is going to be congruent to that triangle. But it also says that this other triangle, the orange triangle, is going to be congruent to the other triangle, to the one completely opposite, because here is another diagonal. Okay, so the top triangle is congruent to the bottom triangle. That's basically what it says down here. Okay, so if we start doing some problems, knowing, and please assume no, do not assume. It's telling you that all of these are parallelograms. So all 6 of these problems, all of them are parallelograms. So we're going to say that all this applies to them. When we go to problem number 1, I can start saying, hey, you know what? 12 is congruent to 3x, and I can say 8 is congruent to 4y. So you can write those equations down. 8 equals 4y, and you can write 3x equals 12. That's the end of the geometry. You do a little bit of algebra now. Divide by 3, x equals 4. And then for the other one, divide by 4, and 2 equals y. And you're done with both, x and y for problem number 1. Problem number 2. Well, again, I see immediately that this is congruent to that. But what else I know? I know that if it's a parallelogram, this happens to be the midpoint of this other diagonal, which means that 4x is also equal to 28. So I'm done. That's all I needed to know. So now I can say 4x equals to 28, and I can say to y equals 28. That's the end of geometry. A little bit of algebra. Let's divide by 4. Let's divide by 4. X equals 7. And let's divide by 2. Let's divide by 2. And we say y equals 14. And just like that, we are done with this problem. Problem number 3. Now for this problem, we are going to use a little bit of previous knowledge to solve this interesting problem. I want you to concentrate your eyes to this triangle, the one that I'm marking right now. Okay? If we concentrate the eyes to this triangle and only this triangle, and I'm gonna say, hey, blue triangle right here, I clearly see these congruency markings. Knowing that those congruency markings are there, I can say immediately that blue triangle is an isosceles triangle. And if that is an isosceles triangle and those are the legs, I know that this base angle has to be congruent to that other base angle. So immediately I can say that the other base angle is 60 degrees. Now I take a look and I say, well, you look at that. That's 60. That is 60. I wonder what this angle is. Well, I know what that angle is. That angle is also 60 degrees. Now that I know that that angle is 60 degrees, then I take a look and I say, but guess what? That angle basically got bisected here. So I know what the red angle is. The red angle is going to be half of whatever 60 is. So half of 60 is 30 degrees. So now I take a look and I say, this is 60. That's 30. Well, there's no other option for this angle over here but to be 90 degrees. Okay? So now we take a look and we look at everything and I say, how interesting. So now I can definitely say, you know what? There are a couple of things that make sense. Knowing this triangle over here, well, 2x have to be 30 degrees. And I take a look at this other triangle over here and it has to be basically the same situation as over there. So basically 4y is also 30 degrees. We are done with all the geometry that we need. Now we know exactly what 2x is. 2x is 30 degrees. We know 4y is 30 degrees. We're done with geometry. A little bit of algebra now. Let's divide by 2. X equals 15. Let's divide by 4. And we say y equals 7.5. And we're done with that problem, problem number 3. Let's take a look at this problem right here. Okay, so again, I see the same situation that we got to see a moment ago. I see a 90-degree angle. I see a 30-degree angle. That means that this angle over here has to be 60 degrees. Okay, and here we have another 60 degrees, 60 degrees, 60 degrees, 30 degrees, 30 degrees, 30 degrees, and 30 degrees. Okay, now let's concentrate the eyes to this triangle right here. I'm gonna make that one the green triangle let's call it the green triangle. And from the green triangle, I see 10, okay? And when I see 10, and that is the short side, y is the long side of a 30, 60, 90. Well, if the 10 is the short side and y is the long side, I'm going to apply what I learned in lesson 8-3, that basically the long side is just going to be whatever the short side is times the square root of 3. So y is just 10 square root of 3. And just like that, and we're going to make a note here from lesson 8-3. We know what y is. And then to finish the problem, I know that I know that this diagonal got bisected. So that means this is congruent to that. So 10 is congruent to 3x. And we're going to do that. We're going to say 10 equals 3x. Well, that is the end of geometry. And we basically now divide by 3, and I can say x equals 3.333, or 3 1/3 equals x. And that is the end of problem number 4. Okay, problem number 5. So we take a look at problem number 5. And what do we see? We see that they're asking us for an x, which happens to be an angle right here. Okay, and we look at this one, which happens to be a side. You see, and the reason why I know this is because, let's see if, I don't know if I can make this a little bit. Okay, do you see that when it says their angle right there? So 3x is referring to the 3x degrees. This is referring to the angle. Over here, I don't have a degree, so on that one, it's referring to the side. So when we look at this problem, I want you to concentrate your eyes to the red triangle that I'm marking. Right now, I see the 90-degree angle. Well, if this one is 90 degrees, then I know that the two base angles over here are going to be 45 degrees and 45 degrees. Okay, so knowing that, I can just say 3x equals 45, divide by 3, x equals 15, and we're done with x. However, knowing that this is a 45, 45, 90, going again to lesson 8-2, well, I know that this is the leg, so this will be the hypotenuse of a 45, 45, 90. So this hypotenuse right there needs to be, sorry, let me zoom again. That hypotenuse right there has to be 12 square root of 2, and that is from lesson 8-3. So knowing that that is 12 square root of 2, I know now that this part of the diagonal will be congruent to that other part of the diagonal. So now I can say 12 square root of 2 is equal to 2y. Done with the geometry, let's divide by 2, 6 square root of 2 equals y, and we are done with the problem. All right, let's go to problem Number 6. Okay, so what do we have over here? Okay, so on this problem, we have a couple of things that we need to say. We need to say that here's a 17, and over here is a 17. Okay, and I can say, so let me write the 17 up here. I see a 4. That means this other one is also 4. Right? So now there are a couple of things that we can do. If we want to calculate for x, and here is x, we can now take the green triangle right there, okay, and we can say that knowing that here is the 90-degree angle, that means this other side is the hypotenuse. So I have a leg and I have another leg. Okay, so now we are going to apply lesson 8-2 to solve this, and I'm gonna say x, let me go over here, I'm gonna say x, which happens to be the leg, is gonna be the square root of the hypotenuse square minus the leg square. From there you say x equals, let me take a look over here, x equals 15. Right, so now I say x equals 15. I can put it also over here. I can say 15. So now, if I want to simplify this a little bit more, I can just pay attention to, let me take another color over here. Let's say orange triangle. Here's the orange triangle. I see the 90-degree angle right here. So I know what this other angle is going to be. It's going to be also a 90-degree angle. So for this time, it's asking for the hypotenuse of this orange triangle. So I'm going to treat it as a Pythagorean theorem. I say y, which happens to be the hypotenuse this time, is going to be the square root of 4 square added to 15 square. And then I say y equals the square root of 2, 4, 1. And I don't think that one simplifies more. And just like that, you have found x and y for this problem. Now let's go for a challenge. This time, it's telling me coordinate geometry. So for coordinate geometry, it says, find the coordinates of intersection of the diagonals of quadrilateral ABCD. So just like that, quadrilateral ABCD, I need to say it order matters, order matters, order matters. Okay, you will have A, B, C, D. Order matters, order matters, order matters. That means your two diagonals are going to be diagonal AC and diagonal BD. So these are your two diagonals. And basically what the question is, where does the two diagonals meet? Knowing that it works like that, I know that AC form a line and BD form another line. Okay? So I'm going to color code this. Let's say AC is the blue line. So I have a line and then I have another line. Okay? And same for the other problem. I have a line and then I have another line. So what you need to do, you will need to apply algebra for this. Number one, you will need to find the slope of the blue line, and then you need to find the slope of the red line. And then you will have to find the equation for blue line and the equation for red line. And after you find those two, then you're gonna do system of equations, and you're gonna find the x and the y that make the blue and red line true. So we're gonna start with blue line, and we need to find the slope first. So slope, from algebra 1, we know that it's gonna be y2 minus y1 over x2 minus x1. y2 is -2 minus y1, 6. x2 is 3 minus x1 happens to be 3. Red line, we have y2, -4, y1, 8, x2, 1, x1, 5. So the slope for the blue line is going to be -8 over 0. That means undefined. And for the red line, we have -12 over -4, and that means +3 for the slope. Okay, so what is the meaning of this? Well, the meaning of this is that if I take a look at the blue line right here, knowing that it's undefined, the only possible line that is going to give me an undefined slope is going to be a vertical line. That means a line that goes up and down. That's the only line. So when I look at this, I see, oh, when you look at that, I have repeating 3's. Of course, this is not a function. I have repeating 3's. That means this line goes completely vertical at x equals 3. So I know the blue line equation. The blue line equation is just x equals 3. So this simplifies a lot, because now knowing that x equals 3, all I need to do is solve this other line, the red line. I need to solve the red line, and I need to find what is the value of y whenever x equals 3. So we're going to do a little bit more algebra now, and we're going to do y minus y1 equals mx minus x1. We are going to plug in everything that we know. We're going to say, I'm going to rewrite it again, and I'm going to start erasing things so that you see where I'm going to plug in every single thing. So I'm going to take out m, and I'm going to plug in the slope that I just found. And the slope that I just found happens to be 3. And where I got that 3 from? From up here, okay? And now I can select any point that I want, okay? Any point that I want for y1 and x1. I like working with positive numbers, so I'm going to work with 5 and 8. So x is going to be 5, so I'm going to take x1 out. I'm going to plug in 5. I'm going to take y1 out. I'm going to plug in 8. So that is my equation right there. And now if I want to change it into y equals mx plus b, we can definitely do that. We can do a little bit more algebra. And I can say y, let me make sure that that looks like a y. Y minus 8 equals 3x minus 15. And we are just going to add 8, and that will be 7. Y equals 3x plus 7. And that is the equation for the blue diagonal. Now remember, oh no, sorry, that is the equation for the red diagonal. Sorry, this is the red diagonals. okay? So now remember that what we learned is that the blue diagonal only have 1 and 1 x, only 1 x. So that will be the only x that will make the equation true. So in other words, all I need to do is take that x and plug it there. So that means that I can say y equals 3 parentheses, 3 close parentheses plus 7, y equals 9. Sorry, this is supposed to be minus 7. It needs to be minus 7 over here because you see I have a positive 15 and a negative 15 and a positive 8. So it's minus 7. And now I say y equals 2. So where does these two diagonals intersect? At x3 and y2. Now you have access to Desmos, and the back of your dry erase board that you have in the classrooms have coordinate grids. So it would have been a lot easier if I can just go to the grid and solve the problem using the grid. So let me give you a demonstration how that looks like. I'm going to do exactly the same problem. I am going to put point A. It was at 3, 6. That is point A. Then let's go to point B. Point B is 5 and 8. That is point B. Let's go to point C. 3 and negative 2. 3 and negative 2. And then finally, let's go to point D. And point D, it's 1 and negative 4. There it is. Okay. So now I am going to look at my parallelogram. There it is. And now all I need to do is draw two diagonals. And here is my first diagonal from A to C. Let me change the color for that one. Let me change it to red so that you can see it. There it is. And then let's do another diagonal and go from B to D. Let me change the color of that one also to, let me change that color to, I don't know, let's make it a blue. There it is. And I can definitely now see my point E that happens to be at 3, 2. Exactly the point that we said that it was going to be. That's the coordinate 3, 2. So that would have been a lot easier way to solve this problem. Just do it graphically with Desmos, or do it graphically on the with the dry erase with the board provided in the classroom. That's the end of lesson 6-2. Basically, the other problem it can be done basically the same way. And we are not covering this in today's lesson. So problem number 8, go ahead, try by yourself. Do it with a dry erase board or do the whole algebra.